Is a curved path which is traced by any object. We take the x and y axis and we locate our origin, and from origin we try to find an instantaneous point where the instantaneous velocity is v, and suppose the coordinates of the, ob- the object or the body is given by p x y, then the position OP of the body at that instant is given by xi plus yj. The velocity is calculated as v is equal to dr by dt, where r represents the position, and when we substitute these values, we get dxi by dt plus dyj by dt. This dx by dt gives the velocity, the x component of velocity, and dy by dt gives the y component of velocity. So it is represented as dx and dy, and the overall resultant velocity is given as v is equal to root of v square vx square plus vy square. Now the acceleration. Acceleration of that particle at that instant is given by dv by dt, where we substitute this value here and we take the we get the double differentiation, d square x by dt square into y, d square y by dt square j. So this gives us the acceleration. The x component of acceleration is this, dx square by dt square, and the y component is this, dy square by dt square. It is given by ax and ay respectively, and then the overall or the resultant acceleration is calculated as ax square plus ay square. Now, uh, now this same diagram we have drawn in magnified form of this diagram. We find the normal and tangential components of acceleration. Suppose this is, again I draw it again for you. This is how our particle is moving. This is the instantaneous acceleration in tangential direction, or which is tangential to the path. It is given by at, and an acceleration towards the center is given by an. And this is normal, and this is called as a normal acceleration. So we get, so at a point there are two accelerations acting, an and at, and the resultant of these accelerations is given by a, where a is the resultant acceleration. This is an angle formed, theta, and theta is given by tan inverse of an by at. So we get the resultant acceleration and the angle made by the resultant. If the particle is tracing a circular path, is absolutely circular, then the radius is given by r of the circle. If this is how it is, assuming that this is a circle, this is r, and this entire thing is 2r, which is equal to diameter. But there can be cases where the path traced is not absolutely circular. It can be something like this. So for such distorted circular path, the radius is calculated by this formula, which is rho is the denotion, or this is how we denote the radius of curvature. It is given by 1 plus dx by dy by dx the whole square, and the entire term has a power of 3 by 2 divided by d square y by dx square. So this is a big formula. It is written in red because it is very important. The other form of representing rho is Vx square plus Vy square the whole raised to 3 by 2 divided by, now pay attention here, it is Vx Ay and Vy Ax. So acceleration of y component is multiplied with velocity of x component, and acceleration of x component is multiplied by velocity of y component. These are the two ways in which we can find the radius of a curvature. Now we look at the sums.